Hi guys, we're going to start today. We're going to be going through some data, statistics, and probability for year 9. We'll start off with that. So let's jump into some statistical vocabulary. All right, let's look at some statistical vocabulary. Hi guys, we're going to start. All right. And let's check that sound there. Okay, so some statistical vocabulary over here. All right, let's look at some common words in statistics that you need to know. And we can maybe think of some examples of it as well. The first word is population. Now, some of you might already know what the word population means. If you don't, a population refers to the entire group of individuals. All right, so it's an entire group of individuals. And it can also be objects, and it can also be events. All right, that someone is trying to study. It could be a study as well. All right, study, some kind of study. An example would be, let's say, the population of United States college students contains 19 million students, for example. That would be a population. All right, it's a group. It's a group with a particular characteristic in mind. All right, so that's population. Let's look at the next word, sample. A sample is a subset of the population. Subset mean that it's a fraction of the population, a part of the population. All right, subset of a population. So if you have some kind of population, let's call it P, inside you can have a sample, which is a part of the population. So a sample is a subset of the population that is selected to represent the larger group. So it's not just anything, not just any group anyway. It's a sample, a subset of the population, which is selected to represent the larger group. All right, represent the larger group of that. Okay. It is used to gather information or draw conclusions about the entire population. And for example, a sample could be a group of 1,000 students selected from a population of students. But remember, these groups will have certain characteristics as well, right? Certain characteristics that are representative of the population. All right, that are representative of that population. Okay. And then we look at the next term, which is census. All right, so census is a study, all right? It's a study or a survey that you do on some population, all right? But you want to gather data from every member of the population. So census is a study or survey to gather data. To gather data from every member of the population. From every member of the population. An example of a census would be the one we conduct maybe every 10 years to gather the total number of people in New Zealand. Okay, it's the form that you fill in, and it asks you different kind of questions. Where do you live? How many children do you have, etc. And with that information, you can gather and make decisions about a population and maybe even serve the population better. Then we got data, the next word. Some people say data. can also be data. Data refers to the facts, figures, and information that is collected. All right, so facts, figures, information that is gathered, that is collected, analyzed, and interpreted. All right, so this facts, figures, and information are collected. So it's collected and we analyze it and we interpret it. The data would be certain characteristics in a census form. Census form could be made up of tick boxes. Whether you're male, female, how old are you, how many people live in your household, etc. And then each of these become data. All right, data, part of a whole in total. So, for example, data could be the number of hours that students spend studying in a week. So data could be total number of screen time that everybody uses in a day. And then you could make decisions about certain things. Maybe in the past 20 years, as computers have increased, we've noticed that reading has decreased. So we could ask, how many books have you read in the last year? And how many of those books were online? And how many of those books were actually physical? How many books have you actually read? And why do we even do that? We can assume things, but statistics gives us a definite answer. It gives us some kind of solid ground to work from to actually make a decision, and a very evidence-driven decision about whether something is true or not. All right, the next word, survey. All right, S-U-R-V-E-Y. A survey is some kind of research that gets done. It's on the data and it's from some kind of sample. All right, so a survey is a research method, and we use it to collect data from a sample of individuals. All right. It involves them. We ask questions and we gather information, right? So we ask questions. A census form is very much like a survey as well. So ask questions and opinions, maybe behaviors, characteristics, etc. An example of this could be, let's say you want to create some kind of Google form, and you send this Google form to everyone in the school because you want to find out study habits. So you display maybe 4 or 5 different questions on a Google form, and you ask everybody, so guys, how many hours do you spend on TV? How many hours do you spend on your screen? How many hours do you spend studying? How many hours do you spend at school? How many hours do you spend sleeping? And from the waking time, you could then make decisions on the survey, which is from a sample that you selected. And how would you create a sample that is reflective of the population? If you look at it, for example, in a school setting, we have, let's say, year 9s, we have year 10s, we have year 11s, and year 12s, and year 13s. If I want to create a sample, I could take, let's say, one student from there, one student from there, one student from each year. And that would be an example that is very reflective of the population. But it could get more intricate than that. It could get more number-driven. Let's say in year 9, we have 300 students. In year 10, we have 200 students. In year 11, 100, 50, and then 25. So how would we choose the sample so that it's reflective of the population? And I mean, this is just an example, but we want to create some kind of sample that would be reflecting everyone's opinions so that everybody gets a fair choice. Once we make a decision about the survey, we want to make sure that that decision or census, that the data and the figures that we gather from the sample, which is from the population, is reflecting the population so that everybody gets a fair opportunity once the decision is made. So you have 300, 200, 150, 25. I could change this into, let's say, I don't know, could be, let's make this one 30. Let's make this 30 so it looks a bit better. So we got, let's say I remove the zeros from each of these, and I get 10 students from year 9. I mean, 30 students from year 9. I send 30 of these forms out. I get 20 year 10s. Oh, I send more than that, and I only use 30. 20, and then 10, and then 5, and then 3 year 13 forms. And then that gets me maybe an accurate percentage. Now, I don't know, that's just an example. It doesn't have to work like that. It could work in reverse, depending on the study that you're trying to perform. Okay, so that's just the idea of reflection of a sample to the population. The next, and that's takes us to the next word, which is representativeness. All right, representativeness. Representativeness is the extent to which the sample actually reflects the characteristics of the population. So it's the one word that actually sums up what I just said. Okay, so reflectiveness is the extent to which a sample reflects the characteristics of the population. An example there we saw in school, we would choose a sample from year 9 to 13. Another example would be students which are chosen from a big population, which is representing a population in terms of age, gender, ethnicity. It could be any specific questions that you have on a survey that gets you a certain amount of data, facts and figures, etc. All right, then we got the word bias and unbiased. Bias refers to any systematic error. Almost like, it sounds like unfair. Bias is unfair, right? So it's some kind of systematic error. Some error in the system. So it could be a deviation from the true value. All right, there's some deviation or movement away from the true value. And bias, the opposite of the word bias is unbiased. And that would be where it is actually fair. And unbiased would mean that it's free from bias, it's accurate, it's reliable. The data we received is reliable, it's accurate. Now I'm going into a lot of depth with each of these terms, but just to give you an idea, an example of this would be when you roll a dice, so you flip a coin. All right, you flip a coin, you can get heads or tails. It's unbiased because each part will be half. But let's say you go to gambling. You go into a gambling place and you're gambling, but you got a special coin. You got a special coin that is slightly heavier on one side. But nobody notices this. And when you flip the coin, it keeps ending up on heads. So you keep maybe betting on heads, for example. I mean, there's many different ways. It doesn't have to be gambling. But for example, that would be biased, unfair, right? Systematic error, deviation away from what it should be theoretically. All right. Biased, unbiased. And then we've got what is known as secondary data. Secondary data is data that refers to, it's been collected by someone else for a different purpose, but can be used for analysis and research. It is obtained from existing sources such as books, articles, databases, previous studies. An example of secondary data would be study habits to inform something that's going to create maybe new research. All right. Primary data comes from the original source. Secondary data comes from a source that someone else provided from. So it's collected by someone else, right, for a different purpose. It's obtained from existing sources. So let's say from books, articles. Instead of sending a survey and getting primary data directly from the population in the sample, we can refer to books and articles, or we could study different websites and different population density data. There's so much of data out there. Could be anything, doesn't have to be that, but from books, articles, etc., and any kind of previous studies that were done already. And you could then justify that. From these studies, the secondary data, I can then decide something, etc., etc. All right, so there's some statistical vocabulary for that part there. Let's have a look. Let's continue into the next one now. So if I have to look at maybe categorical data, numerical data, and different types of graphs, let's have a look at what is the difference between the following. All right, what is the difference between qualitative data and quantitative data? All right, let's put two big words up here. Qualitative. Now, qualitative data means that it's not a number. All right, to put it plainly, not a number. It has a quality to it. An example would be if you have red or blue. It's not a number, it's a color. If somebody is happy or sad, actually, I'm not sure if that's actually going to be something that's more abstract. But look at something that you can actually substantially look at, like passing and failing. It's countable, right? Actually countable. I mean, happy and sad could not be countable based on what people smile. I'm not sure. Could be survey driven, could be opinionated based. All right. But qualitative data here, we can distinctly say red, blue, we can see it, pass, fail, we can actually see it after you've written and it's marked. All right. And something that is different examples of qualitative data that you can think of. All right. Could be different types of large, medium, small, etc., different components of a whole as well. All right. So pass or fail, etc. And let's say you want to grab information from customers about the satisfaction of a product that you're selling. So you ask them for opinions, experiences, etc. Qualitative data, you can analyze patterns, trends. All right. So allowing researchers to actually think about creating different kinds of conclusions about complex things. All right. So it's non-numerical, it's descriptive in nature. You're describing something, it's the characteristics of something, it's the attributes of something. All right. It's collected through observations, through interviews, open-ended questions, focus groups, etc. That's qualitative. All right. Let's look at the next one. The next one is quantitative. Now, in terms of actually pronouncing this, quantitative. All right, quantitative. I'm going to say quantitative data. All right. An example. Now, this is numerical. What does numerical mean? Numerical means it has a number in it. It means that you can actually supply some kind of number to it. An example of this would be the length. It could be meters, centimeters, kilometers. It could be quantitative time, seconds, hours, days, weeks, years, etc. Could be mass, all right, which is grams, kilograms, etc., tons. And what else? Weight, mass, time, capacity, liters, kiloliters, etc. Those are qualitative, all right? Quantitative data is numerical, right? Quantitative versus qualitative data. Remember that it's basically also, once you have numbers, you can actually develop relationships and trends because of these different observations. Maybe you supply in surveys, we were saying, and you're getting the data would be quantitative, right? It's you counting it, right? It's countable, or it's something that can be measured, all right? Quantitative data is also the ability to predict or test or hypothesize something, create some kind of, once you have enough data, you can maybe predict the future or predict what's going to happen next. An example, let's say you toss a coin and you don't know if it's biased or not, all right? So you keep tossing the coin, you get heads, tails, heads, tails, heads, tails, and all of a sudden you get tails, tails, heads, tails, heads, and you just keep getting more tails, for example. And then you realize, okay, well, you know what? I'm getting so many tails. Let me check the coin. The coin is biased. All right. So counting that would be quantitative, where you actually can see the amount of heads and tails as well. All right. And that would be where you're actually getting some kind of hypothesis from it. All right, qualitative, quantitative. The next two descriptions or vocabulary would be discrete and continuous. You get discrete data and you get continuous data. Discrete data is something that can be counted, all right? It is, for example, the total number of cars that are passing a certain point. So discrete data versus continuous data is discrete can be counted. So you can actually see 1, 2, 3, 4, 5, 6, 7, 8. That's discrete data. But continuous data will have decimals. For example, heights, all right, the height of students. It can be 1.27653 meters, all right? That could be the height of something. And discrete data is counted, the total number of people, let's say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's discrete data. Whereas continuous data is a measure, all right, some kind of measure. It's the numerical information that's over a certain range. The quantities are infinitely divided into smaller and smaller units that you can possibly find. Whereas discrete data is whole number values, like 15 or 20 or 25. It can't be a fraction or a decimal, okay? So we must remember that. So discrete data, no decimals. Okay, no decimals. Continuous data, decimals allowed. Okay. And if we keep going, I mean, in this description of data and statistical vocabulary, we can now move on to some graph types. Let's have a look at different types of graphs that we can get. All right, the first type is a pictograph. All right. So what we need to do is, what does the word picto come from? Where does the word picto come from? It comes from the word picture, right? So pictograph uses pictures or it uses symbols and they represent data. This is more engaging. It helps people to understand. It's more easy to understand pictographs. Okay. And then you get the next one, which is your bar graphs. Bar graphs are like rectangular bars of equal width. So bar graphs would be in it. If you have some kind of data set, you would have rectangular bars. Rectangular bars that look like this. There's one, maybe another one there. I'm sure you've seen a graph like that. And normally they have the same width. I'm just drawing this randomly. Right, that would be a bar graph. And then you have the next one, which is your strip chart. The strip chart is also known as a dot plot. And a dot plot, they use dots or points to represent data. So a dot plot, for example, would mean that you're just going to provide dots on a line. And then if there's many dots in a certain category, it would pile on top of one another. So let's say you got 0, 1, 2, 3. The total number of hours students spend watching TV after school. 0. Okay, well, let's say screen time. 0. None. 1 student. 2. 3. All right. 4 hours. All right. 5 hours. 6 hours after school. Non-stop. All right. I don't know. That data is true. But anyway, that's a dot plot. Okay. So we got graph types, dot plots. Let's move into the next one, pie charts. Just like a pie is round, a pie chart is a circle that's divided into slices of different sizes. It doesn't have to be different size, but it normally is. And each proportion or percentage is a category. So let's say this is A, B, and C. A, the total number of people that have red hair. B, total number of people that have blonde hair. And C, total number of people that have black hair. And this would be a percentage. This would be a percentage. And let's say this is 50%. It looks like half. This looks like less than 25%. So let's make this 15%. And so this would then be 35% because it adds up to 100%. That would be a proportion. That would be your pie chart. And you could also use degrees. Remember, this is 180 degrees, etc. 50% of 360 degrees would get you that for that. Now remember, these over here, by the way, are all known as categorical. Okay, so there's a big word over here, categorical. Because everything is in categories. Category A, B, C, D, E, category 0, 1, 2, 3, 4, 5. Pictures are categories. Pie charts, A, B, C, categories. Everything is categories. Okay. Let's go to the next one, and we'll get a defining word that describes this one as well. The next one is your histogram. Now, what is a histogram? Okay, still on graph types. Okay, we're still on graph types, so we were there, still there. We're continuing into not categorical. Let's have a look at this one now. So graph types continued. First one is your histogram. A histogram is a graph that uses bars to represent the distribution of numerical data. It's similar to a bar chart, but there is no space between them. And it can be of different widths. So it can be one short one, one thin one high one, one low one. And they all right tightly packed next to each other. You can see there's no spaces between them. All right, some X and Y value that we're comparing, etc. So histogram uses bars. It's the frequency that we normally have or displays and some width intervals in between. We visualize shape, center, spread of certain data, etc. All right, and we got our dot plot. All right, dot plot. Now, I think we just did a dot plot, which was a strip chart, but just got to double the dot plot, known as a dot chart, dot graph, uses dots to point, represent individual data for displaying numerical data. I would say this is actually categorical. So let's go back possibly out of there and let's do the next one, which is your stem and leaf plot. All right, you got your stem and leaf plot. Your stem and leaf plot is a graph that organizes your data into stems and leaves. It's a visual representation of actual data values while preserving their own individuality. So I guess a dot plot is going to be a part of this, and I'll tell you why later, but because we're going to have a not categorical, but another name for this set of histograms and stem and leaf plots, etc. So what does a stem and leaf plot look like? It's some kind of stem, and let's say you go 1, 2, and 3, and then you supply leaves on the side, both sides or one side, let's say in alphabetical order. That will be 12, for example, 13, 14, 15. You take the 1, combine it to each number, and it becomes more than that. If you put a 0 over here and put 1, 2, that would be 1 and 2. Let's say you got 4, 7, and 8. That would be 24, 37, 38. So how would I write all of these numbers on a normal data? This would be 0, 1, which is 1, 0, 2, which is 2. Then we got 12, 13, 14, 15. Then we got 24. And we got 37. And we got 38. And then we're done. And we're now taking that, putting it into a stem. And each of these branches coming across are your leaves. And it can be on either side. If you have two sets of data, A and B, you could compare them. So A would be a different set, and you could extend it on either side. Stem and leaf plots. Then we have what is known as a scatter plot. Just like the word scatter, we have these dots everywhere. And let's say the dots are in such a way that if we're comparing two sets or X and Y, we don't know what it is, but let's just say hypothetically, it ends up like this. We can see that there is a trend. We can draw a line of best fit. We can see that there's a relationship. As X is getting more, what's happening to Y? Y is getting more. So if you go to any point on this line, you can see that if I go here, I've got a bigger X value and a bigger Y value. If I go here, bigger and bigger, etc., etc. And it's coming from each point, this point, that point. And every time I increase a point, it seems like both sides increase more often than not. And then I have this over here, which is not on the line. We call that one an outlier. It's away from the line. Okay, it's not part of the group. So it's outside of the group. So it's an outlier. Okay, lies on the outside. Okay, scatter plots. Scatter plots represent a relationship between two numerical values, like, for example, X and Y in this case here. Patterns and trends, correlations between two variables are found. All right. Then we have what is known as your line graph. Line graph uses lines to connect data points showing relationships between two numerical values. So instead of drawing a line through it like a scatter plot, you have certain points like this, and you connect a line through it, through each point. So like this, and there, and well, you don't normally use these really big crosses. I mean, we just use really small crosses and connect. I'm just going to connect lines to certain parts of a graph. I don't know, it could go all the way down, and it goes up, etc., etc. All right, that would be your line graph. Very roughly drawn. Okay, very roughly drawn. This would be an increase in the x-axis and the y-axis. And wherever there's a point, we would connect that point from one line to the next. So you can actually see the trend. Oh, it's going up, up. Oh, there it goes down. Rainfall decreases from March to April. Or no, March to May. Okay. For example, that would be your line graph. Line graphs. Now, what are all of these called together? Remember the previous one we said are categorical. Now, because these have numbers in them, we call these numerical. All right, so the big word here at the top would be numerical. Versus categorical. Okay. All right, and that's all the different graphs types, etc.